So let's have here our first problem. For the inclined planes, what is the coefficient of static friction between a 20 kg wooden crate and the concrete ramp 30 degree that is sitting on? So first, if we're gonna imagine the scenario here, we're gonna have a 20 kg, okay, wooden crate, and then it will gonna have a 30 degree angle from the incline. And so we're gonna identify all the forces on this part, and take note that this wooden diagram is on static friction, and that means on it stays on the ramp. It's not moving down, it's not moving up, so it's just on stop, or it has no motion. So from here we can draw the free body diagram, wherein the value of weight is equals to mg, and we all know that the weight here, that would be 20 kilograms multiplied to 9.8 meters per second square, and that weight would be 196 newtons. Now, if we will try to identify the forces here, we could say that we're gonna have the force parallel, or simply the weight parallel. And we all know that the weight parallel from our previous discussion, that would be equal to sine of 30 degrees multiplied to 196 newtons. Or by the way, the formula would be weight parallel, that would be sine theta multiplied to mg, and mg is already 196 newtons. And next, we could identify also, we're going to have a frictional force out of it, and also we're going to have the force perpendicular, or simply the weight perpendicular. And the force perpendicular, or the weight perpendicular, that would be equal to cosine of theta mg, and therefore that would be equal to cosine 30 degrees multiplied to 196. We already computed for the mg, and that would be equal to 169.74. Okay, and of course, aside from the force perpendicular, the counterpart of that would be the normal force. Now let's try to identify what are the summation of forces in the x and forces in the y. So we have here in the y-axis, and next we have here the x-axis. Now the summation of all the forces coming in the x, that would be the force parallel minus the friction. And since we all know that it's not moving in x, so the box is not going down, it's not going up, it's just stay on that position. So therefore the sum of the forces would be 0, and 0, that would be force parallel, or the weight parallel minus the friction. And we know that friction is equals to force parallel, and we already computed for the force parallel, which is sine 30 multiplied to 196. Let's try to compute on that. Sine 30 times 196, that's 0.5 of 196, that is 900 newton. So here the value is 98 newton, sorry for that. So that would be 98 newton. Okay. Next, if we're gonna do the summation of Fy, let's try to do the summation of Fy. The summation of Fy here would be the normal force minus the perpendicular force. However, if we're gonna look on this part, the diagram or the box, it's not moving up or not moving down in its axis, and therefore the summation of forces in the y would be 0. And so we're going to have the normal force minus the force perpendicular. And we all know that the normal force is equals to force perpendicular. And so the normal force here will become the perpendicular force. And we computed already for the perpendicular force, which is cosine of 30 multiplied to 196. And the normal force would be 169.74 newtons. Now, let's try now to define what is the value of the mu static. The mu static would be force over the normal force. If you try to recall the formula that the frictional force is mu static multiplied to normal force. And so deriving for the mu static, that will be equal to force over the normal force. And so that would be 98 newtons divided by 169.74 newtons. And pressing that on calculator, that would be equal to 0.557. And since it is coefficient of static friction, that is unitless. So this will be our final answer. Now, there's a shortcut way of doing that. If you want to know the shortcut way of doing that, let's try to see what will be the shortcut formula if we want to look at the static friction. If we want to look at the static friction, first, we will try to get this concept. So we're going to get this concept here for the summation of fx. So for this part, I'm going to paste it here. And what will be the sum of all, what will be the friction? The friction will be the force parallel, which we all know that is sine theta mg, right? And likewise, we're going to have this concept and that would be the normal force is equals to cosine theta, which is the cosine theta mg, which is the force perpendicular. And since we define mu s as the static, that is F over Fn, and then we could have here the frictional force, which is sine theta mg over cosine theta mg. And so we could cancel out the mass and the gravity, and then we're gonna left out with sine theta over cosine theta. And you all know that this function, which is sine theta over cosine theta, that would be equal to tangent theta. So the shortcut here from the problem, if you want to solve the problem immediately for the coefficient of static friction, just press here tangent of whatever that angle is, tangent of 30 degrees. And if you're going to press that in your calculator, that would just be equal to 0.557. Of course, that would be 0.58 for two significant figure. And that's it for problem number 1. It's either you could prove it in this way, or you could just press for the coefficient of static friction, you could just press the tangent of that angle, then it will gonna give you the right answer. Now, take note that as soon as you increase the angle of inclination and as soon as you see the movement of this box, then that would be the angle for the coefficient of static friction.